This is part 31 of my preparation for exam NSE4 FortiGate. Let's talk about primary FortiGate tasks. Broadcasts hello packets for member discovery and monitoring. Broadcasting hello packets and listening to hello packets from other members in the cluster. The members use the hello packets to identify if the other FortiGate devices are available and alive. The primary FortiGate also synchronizes its operation-related data to the secondary members. Some of the data synchronized includes its first configuration, second FIB entries, forwarding information-based entries, DHCP leases, dynamic host configuration protocol leases, ARP table, address resolution protocol table, forwarding definitions, IPsec tunnel SAs, security associations, and sessions must be enabled. Note that some parts of the configuration are not synchronized because they are device specific. For example, not synchronized the host name, HA priority, and HA override settings, enabled or disabled, they all are not synchronized. Optionally, you can configure the primary FortiGate to synchronize qualifying sessions to all the secondary devices. When you enable session synchronization, the new primary can resume communication for the session after the failover event. The goal for exiting sessions to continue flowing through the new primary FortiGate with minimal downtime or with no interruption. We will study types of the sessions that we can enable synchronization. In active mode only, a primary FortiGate is also responsible for distributing sessions to secondary members. Secondary FortiGate tasks. Broadcasts hello packets for members and for member discovery and for monitoring purposes. Second FortiGate task, which is secondary, is in active passive mode. The secondary devices act as standby devices, receiving synchronization tasks, synchronization data, but not actually processing the traffic. If the primary FortiGate fails, the secondary devices elect a new primary. They synchronize data from the primary and monitor health to the primary. In active mode only, FortiGate processes the traffic distributed by the primary. The devices don't wait passively. Heartbeat interface IP addresses. FortiGate clustering protocol FGCP automatically assigns the heartbeat IP addresses based on the serial number of each device. The IP address, for example, 169.254.0.1 is assigned to the device with the highest serial number. IP address 169.254.0.2 for the second highest serial number, 169.254.0.3 to the third highest serial number, and so on. The IP addresses assignment does not change when a failover happens. Regardless of the device role at any time, is it a primary device or a secondary, its heartbeat IP address remains the same. The change of the heartbeat IP address may happen when a FortiGate device joins or leaves the cluster. In those cases, the cluster renegotiates the heartbeat IP address assignment, this time taking into account the serial number of any new device or removing the serial number of any device that left the cluster. The HA cluster uses the heartbeat IP addresses too. First, to distinguish the members. Second, to synchronize data with the members. Heartbeat and monitored interfaces. Heartbeat interfaces exchange sensitive data and may use a fair amount of bandwidth for data synchronization. For this reason, if you use a switch to connect the heartbeat interfaces, it is recommended that you use a dedicated switch, or at least that you place the heartbeat traffic on a dedicated VLAN, virtual local area network. In addition, if you must configure at least one port for a heartbeat interface, but preferably it's better to configure two for redundancy. For heartbeat interfaces, you can use physical interfaces only. That means that you cannot use VLAN interfaces, IPsec VPN, you cannot use redundant IP interfaces, or 802.3 aggregate interfaces. You can use only physical interfaces. For link failover to work, you can configure one or more monitored interfaces. A monitored interface should be an interface whose failure has a critical impact on the network and therefore should trigger a device failover. For example, your LAN, local area network, or WAN, wide area network interfaces are usually good choices for monitored interfaces. Heartbeat interfaces, however, should not be configured as monitored interfaces because they are not meant to handle user traffic. Note that you can monitor physical ports, redundant interfaces, and LAG. LAG stands for link aggregation group interfaces. Don't monitor heartbeat interfaces. Configure link failover after the cluster is formed. It prevents unwanted failover events during initial setup. As a best practice, wait until a cluster is up and running and all interfaces are connected before configuring a link failover. This is because a monitored interface can be disconnected during the initial setup and as a result trigger a failover before the cluster is fully configured and tested. HA Complete Configuration Synchronization. To prepare for failover, an HA cluster keeps its configuration in synchronization. FortiGate high availability uses combination of both incremental and complete synchronizations. When you add a new FortiGate to the cluster, the primary FortiGate compares its configuration checksum with new secondary sums that don't match. The primary FortiGate uploads its complete configuration to the secondary FortiGate. So one FortiGate primary, second FortiGate secondary, new secondary, and there is a configuration that moves from primary to secondary. HA Incremental Configuration Synchronization. After the initial synchronization is complete, the primary sends any further configuration changes made by an administrator to all secondary devices. So it sends from FortiGate primary to FortiGate secondary. So incremental synchronization, it sends only that increment that changed between those two configurations, and complete it sends the whole configuration from primary FortiGate to secondary FortiGate. So for example, when you create a FortiGate address object, the primary doesn't resend its complete configuration. It sends only the new object. HA Configuration Synchronization. HA propagates more than just configuration details. Some runtime data, such as DHCP leases and FIB forwarding information base entries, are also synchronized. Dynamic data, such as DHCP leases, FIB entries, IPsec essays, security associations, and session information, they are all for incremental synchronization. The cluster checks every 60 seconds to ensure that all devices are synchronized. And if a secondary device is out of sync, its checksum is checked every 15 seconds. If the checksum of the out-of-sync secondary FortiGate device doesn't match for 5 consecutive checks, a complete recursive synchronization to that secondary device is done. What is not synchronized? These configuration settings are not synchronized between cluster members. HA Management Interface Settings. The HA reserved route for the reserved management interface. In-band HA Management Interface. HA Override is not synchronized. HA Device Priority. HA Virtual Cluster Priority. FortiGate Host Name. Ping Server HA Priorities. The High Availability Priority HA-priority setting is for the ping server or date gateway detection configuration. Also, what is not synchronized, they are licenses. Licenses are not synchronized except FortiToken licenses. Which licenses? FortiGuard license, FortiCloud activation, and FortiClient licensing. And cache is not synchronized. FortiGuard web filtering and email filter, web cache, and so on. The primary FortiGate synchronizes all configuration settings. See you in the next video.